Welcome to the deep dive. This session is really for you, the Java developer, looking at all this AI stuff happening.
Yeah.
And wondering, okay, how do I actually get these, massive changing models into my Spring app without like tearing everything down and starting over? So, our mission today, purely tactical. We're doing a deep dive into the source material on Spring AI. We're going to skip past the fluff, the high-level stuff,
Yeah.
and get straight into the code, the implementation. How you load a model locally, maybe with a llama, and then how you get structured results back inside Spring Boot.
Yeah, and it's really about that abstraction challenge, isn't it? It's a real hurdle for engineers. I mean, the landscape's kind of chaotic. You've got open source things like Llama running on your machine. Then you've got the big remote ones, OpenAI and others, and they all talk differently. So the core question is, how do I write stable Java code application logic that lets me switch? Switch between local, remote, different vendors without a major rewrite. And Spring AI, well, it's aiming to be exactly that layer of stability we need.
Okay, so just to make sure we're all on the same page, let's quickly frame the AI part. At its core, AI is about getting machines to act smart, right? Learn, decide, solve problems. You see it everywhere, like recommendation engines or the brains behind self-driving cars.
Exactly. And what's driving that is the AI model itself. Think of them as these complex mathematical systems. They're trained on absolutely massive data sets to spot patterns, make predictions. And as a developer, you tend to bump into them based on the job they do. You've got your chat models, ChatGPT, Llama for generating text, or maybe text image like DLE. And then the more foundational stuff, image classification models like ResNet.
Right. And that leads straight to this big decision developers face. Do I run this model locally or use a remote service? If you go local, it's running on your own hardware. The huge wins there are data privacy, security.
Yeah.
Your sensitive stuff stays put. Plus, you've got total control for tweaking it. And there are great free options now, like Meta's Llama, Mistral, Microsoft's Phi.
And then the remote models, well, they offer easy scaling, maybe simpler setup because the provider handles the back-end mess. But the reason there's so much buzz around local models and this need for abstraction, it comes down to the sheer scale and cost of building these things in the first place. Let's just look at the stats we have from Meta's Llama 3.1. That gives some real perspective. Trained on over 15 billion tokens, that's about, 60 terabytes of data? And the compute needed, 30 million GPU hours on 16,000 top-end NVIDIA H100 GPUs.
Wow.
Just buying those GPUs, you're looking at maybe €500 million. Just for the hardware.
$500 million.
And the power. For that training run alone, estimated 21,000 gigawatt hours. That's like 3 times what Luxembourg uses in a year.
That cost is just mind-blowing. But okay, if the big providers are spending that kind of money, why are developers still so focused on running models locally? And why is this abstraction layer so critical for, serious applications?
Control and security. Simple as that. If you're building enterprise software, you just can't bet the farm on a third-party black box for your core functions. And you definitely can't risk sending proprietary data over public APIs all the time. It's too risky. So the only way to really guarantee stability and lockdown security is to control the execution, whether that's on-prem or in your own controlled cloud space. And that's why we need great local tools and ways to switch easily.
Okay, so tools. Let's talk tools. If you want to run these big models locally without needing like a PhD in data science done INch, you look at things like Llama, or local AI is another one. Llama is really neat because it gives you this smooth, standard way to manage and run local models. Makes it way more accessible for developers. And using it from the command line is pretty straightforward. You install it, you start the service, Llama Surf, and boom, you got a local endpoint. http://localhost.11434. You can see what models you have installed with the Llama list. Need a new one? Say Llama 3.2. Just a Llama pull Llama 3.2. Simple.
Right. And you can test it right away. Like that example, a Llama run Llama 3, write a dating profile, 20 words, gets you a quick result. But for real applications, we need to embed this. Yeah. Not just run scripts. And the key thing here, the really smart move, is standardization. Developers need interfaces that don't lock them into one vendor. Now, Meta APIs isn't like a formal standard everywhere, but what tools like Llama do is they deliberately mimic widely used APIs. Specifically, the OpenAI API spec is very popular.
Oh, okay.
By doing that, they build in portability. So the code you write to talk to your local llama.can, maybe just by changing a config line, talk to a remote OpenAI model instead.
That makes sense. That standardization is what makes it practical. You're not coding against some weird vendor-specific HTTP thing anymore. It's like a common language.
Yeah.
And for us Java folks, yeah, there are libraries like LangChain4j, but if you're already in the Spring world, the most natural fit, the idiomatic solution, is definitely the Spring AI project. Now, Spring AI is pretty new, right? Needs Spring Boot 3.3 at the moment, but it's built on all those solid Spring principles we know. And the goal is clear. Abstract away the model integration part for chat, for images, even for vector databases.
Exactly. And this is where that Spring magic really shines, I think. Spring AI pulls off this abstraction using something very familiar. Spring Boot starters want a llama. Includes Spring AI, Spring Boot starter. That's it. Decide later you need OpenAI. Swap that dependency for OpenAI Spring Boot starter. And the really powerful thing for you as a developer is the vendor's API just vanishes. It's gone. You're only coding against these general Spring interfaces. It's basically dependency injection, but for large language models.
Right.
Swapping providers literally becomes like changing a bean definition in your config.
That's the big win, isn't it? You learn the Spring AI way, not 5 different vendor SDKs.
Precisely. And it goes further into the data side, too. For serious apps needing memory or semantic search capabilities, Spring AI supports vector databases, which are crucial for handling embeddings. It gives you standard ways to talk to PostgreSQL with pgvector or Elasticsearch, Chroma, Pinecone. It's providing that enterprise-ready data layer for AI stuff.
Okay, let's switch gears. Let's look at the actual code, the workflow. So we've got Llama running locally. We added the Spring AI Llama starter dependency. Configuration seems minimal. Maybe just tell it the model name and application.properties, like spring.ai.llama.chat model, Llama 3.2.
Yep. And right away, Spring makes the core component available through dependency injection. The chat client. This is your main entry point. It's vendor neutral. It's how you talk to whatever model is configured underneath. And the great thing is, using chat client feels like using Spring Data or REST template. It's just standard idiomatic Java. Doesn't matter if Spring auto-configured it or you built it manually, the flow is the same. Get the chat client, create a prompt, then execute it with call or stream.
And the prompt itself, that's your actual query to the model. You can just send a simple string, sure. But for dynamic stuff, you need something better. That's where prompt template comes in handy. It lets you use placeholders like standard templates to build prompts dynamically from your application data. Like that unicorn example in the source material. Write me a brief dating profile of gender unicorn age. You use the prompt template to plug in variables, say male for gender, 165 for age, and it builds the final prompt cleanly. No messy string concatenation.
Then, getting the response back, you've got 2 main ways. For a simple, complete answer, you use call. That's synchronous, waits for the full response. But if you're building, say, a chatbot UI, or the model might generate a lot of text, you use stream. That gives you the output piece by piece, which feels much more responsive. And getting the actual text out, the easy way is just content. Gives you the raw string. But for more complex stuff, you probably want the structured response via chat response. That returns a chat response object. Inside that, you get generation objects, the actual messages from the model, plus important metadata. Things like how many tokens were used, maybe latency info. You absolutely need that structured data for proper logging, monitoring, maybe even billing in production apps.
Okay, basics covered, chat client, prompts, getting responses. Now let's look at the advanced features, the stuff that takes us from just a cool demo to something you can really build robust enterprise apps with. There's function calling, REG. Which one do you think is most critical for making these AI integrations truly reliable in a business context?
Ooh, good question. I'd lean towards RAG being critical for accuracy and trust in enterprise settings. But function calling, that probably unlocks the widest range of new things you can do. But let's start with something maybe less flashy, but fundamental: output structuring. First, data conversion. Look, models are great at spitting out JSON. Developers, we hate manually parsing raw JSON strings. It's tedious, error-prone. Spring AI offers things like bean output converter. You tell the model you want structured JSON back, and the framework can automatically map that JSON straight into your Java objects, your POJOs.
Oh, nice.
It just handles it. No more writing boilerplate parsing code.
That's a huge productivity boost right there. Forget rejigsing the output.
Absolutely. Then, second, function calling. This is where things get really interactive. It lets the language model itself trigger external actions. It can call functions you define in your Spring application. Think about it. The model needs current info. It can call a function to fetch a customer record from your database, or check a livestock price, or call another microservice. So the model isn't limited to its training data from months ago. It can pull in real-time specific context before it generates the final answer. That's powerful.
And that ties into RG, right? Grounding the model with specific, relevant data.
Exactly. RAG retrieval augmented generation. This is vital for trustworthy answers, especially with your own company data. Think of it like giving the model an open book exam, but the book is your internal knowledge base. So a user asks something specific to your business. Instead of just letting the generic LLM guess, your application first does a quick search in a vector database. It finds the most relevant documents or paragraphs from your own data. Then it takes that relevant text and sticks it right into the prompt it sends to the LLM. So the LLM formulates its answer based directly on that accurate, up-to-date, proprietary information you just gave it. And Spring AI has components like Question Answer Advisor that help streamline this whole process, the vector search bit and the LLM call bit. This is really the path to building AI apps that businesses can actually rely on for correct information.
And it's not just text anymore, is it? The framework seems to be looking ahead. We see starters for image generation, OpenAI, Stability AI, and the roadmap seems to point towards audio too. Transcription, analysis, maybe even synthesis, seems like it's heading towards multimodal apps.
Yeah, definitely. The goal seems to be a unified abstraction layer, whatever the modality. But what's really key, the main takeaway, I think, is that Spring AI brings that necessary architectural stability to a very volatile field. By using these familiar Spring patterns, these swappable starters, Java developers can shield themselves from the constant churn of vendor APIs. You get to focus on your application's logic, not the low-level plumbing of talking to this model or that model. It makes it portable.
So boiling it down, what this really means is you can now integrate these huge local models or complex RAG systems using the same Spring patterns you already know. That's a massive step for the Java world, wouldn't you say? It takes AI integration from being this exotic, difficult thing and makes it feel like just another manageable component within your Spring application context. Okay, so here's a final thought, something for you to maybe chew on. We talked about the staggering cost and scale needed to train something like Llama 3.1. Hundreds of millions in hardware, massive power draw. Given that reality, how will you strategically decide on the right mix for your next big project? How much do you rely on smaller, secure local models versus bigger, maybe more capable, but remote models? Where do you draw the line to balance performance, features, cost, and that all-important data security? The tools, like Spring AI, are maturing fast. The strategic choices, those are now increasingly yours to make.